Hi, hello everyone. Welcome back to our channel RL Lab. We were discussing about first chapter real numbers of 10th class mathematics, right? So far we have completed 4 exercises. So today we will try to see about 5th exercise, that is regarding logarithms, right? So let us define what is logarithm in this. First of all, what is meant by logarithm we need to know, right? So let us assume that let a and n are two positive integers, and a must be non-zero, a must be not equal to 1. Then there exists a rational number x such that a power x is equal to n. Then we say that logarithm of n to the base a is called logarithm of n to the base a is called x. Then we say that logarithm of n to the base a is called x. We write it as x is equal to, or else logarithm of n to the base a is equal to x. This is the logarithmic form, right? Just try to read out this logarithm. Let a and n are two positive integers, a is not equal to 1. Then there exists a rational number x such that a power x is equal to n. Then we say that logarithm of n to the base a is called x, and that symbolically we will write it as logarithm of n to the base a is equal to x. This is the formation, right? So if a power x is equal to n, if and only if log n to the base a is equal to x. What does this means? If this happens, then this will happen. This will be the conclusion, right? If this is given, then this will be the conclusion. What is this? This is the exponential form of this logarithmic form. This is the exponential form of this log n to the base a is equal to x. And this is the exponential form of this logarithmic form. Means exponential form of log n to the base a is equal to x. Okay? If a power x is equal to n is the exponential form, then its logarithmic form is log n to the base a is equal to x. Or else log n to the base a equal to x is given. If you want to write in exponential form, then a power x is equal to n. Clear? So if you see few more definitions of this along with the examples, then you will come to know. Okay? So let us see examples. It's very simple. Let us cross check with an example. I am writing 3 to the power 5 is equal to 243. This is the exponential form. If I want to write this is in logarithmic form, so what is, if a power x is equal to n, what will happen? X is equal to log n to the base a, it becomes. Means this power becomes equal to, right? So 5 is equal to logarithm of n is nothing but here 243. What is base? 3. So this is the logarithmic form of this exponential form. The logarithmic form of 3 to the power 5 is equal to 243 is 5 is equal to 243 to the base 3. Clear? You take one more example. Let us say another example. Suppose 1 by 2 whole cube is equal to 1 by 8. 1 by 2 whole cube is equal to 1 by 8. Here what is exponential? This is exponential form. What is the logarithm? 3 is equal to logarithm of 1 by 8 to the base 1 by 2. Clear? Let us say one more example. X to the power 1 by 2 is equal to root x. X to the power 1 by 2 is equal to root x. Now what is the logarithmic form? Logarithmic form of this is 1 by 2 is equal to, this power is equal to logarithm of right hand side root x to the base x. Clear? This is an exponential form, this is the logarithmic form. Right? In all these three cases, exponential form is given, we have written it's a logarithmic form. Clear? According to this. Suppose if a logarithmic form is given, then how to write its exponential form? Let us see. Logarithm of 64 to the base 2 is equal to 6. Logarithm of 64 to the base 2 is equal to 6. Its exponential form is base to the power. See here, x is equal to log into the base m is a power x is equal to n. No, this is what exponential form, right? Base to the power, this is the RHS side number equal to this n. So base to the power RHS 2 power 6 is equal to 64 is the exponential form of log 64 to the base 2 is equal to 6. Clear? Next, some other example if you take up. Suppose logarithm of some same 64 to the base 4, or else let us say 512 to the base 8 is equal to 3. Logarithm of 512 to the base 8 is equal to 3. Its exponential form is same, base to the power RHS number is equal to base to the power RHS number 8 power 3 is equal to 512 is the exponential form of logarithm of 512 base 8 is equal to 3. Clear? These are the examples. If they given exponential form, we can able to write its logarithmic form, right? If they given logarithmic form, if it is required to find the exponential form, then this is the way to find the exponential form. Clear? Right. Let us see laws of logarithms now. Okay? Right. Right. Laws of logarithms. Before proceeding with this laws of logarithms, you need to note two more definitions. That is common logarithm. Common logarithms. Okay. So common logarithms are nothing but logarithms with base 10. Logarithms with the base 10 are called common logarithms. Logarithm with base 10. Log x to the base 10. Log 2 to the base 10. Like this. Logarithm of any number with the base 10 are called common logarithms. These common logarithms generally we written as, sometimes we write as log x. If there is no base, then we have to think that it is a common logarithm. There is a base 10. If there is no base, we have to treat it as there is a base 10. Clear? In few cases, there will not be base. So what we have to assume? There is a base 10. Clear? They are called common logarithms. And one more logarithm is there. That is natural logarithms. We will not use in this chapter, but try to know the definition. Natural logarithms. Simple natural logarithm is logarithms with base e. Base e. Logarithms with a base e are called natural logarithms. Clear? This e value is 2.7 something you will take. Okay? These logarithms with the base e are called natural logarithms. E value is 2.7. So this generally in few cases log x to the base e also written as ln x. Ln x means logarithm of x to the base e. Logarithm of x to the base e. Please be remember, we will use only common logarithms in this chapter. Means log x to the base 10. Common logarithms are nothing but log x to the base 10. Suppose if there is no base is mentioned, we have to treat it as 10. Clear? So now let us see what are the properties or what are the laws of logarithms exist in this particular chapter and how we'll use those, right? We have a proofs also. I'm not going to discuss about proofs here. Just I'll try to write only formulas, right? Yeah, for all the formula, for all the laws, this is the condition. Here m comma n and a belongs to positive real numbers r plus m n and r belongs to r plus and a must be not equal. A must be not equal, right? So first law of logarithm or else logarithm of product. For law of product, right? First law of logarithm or logarithm of a product. So log m into log m n to the base a. Log m into n to the base a is equal to logarithm of n to the base a plus logarithm of n to the base a. This is the first law of logarithm or else logarithm of a product. So logarithm of m into n can be written as log m plus log n. Same base you will get, right? Next, second one, logarithm of a quotient or second law of logarithm. Logarithm of m by n to the base a is equal to log m to the base a minus log n to the base a. Clear? Next, logarithm of exponent or third law of logarithm. Logarithm of exponent is logarithm of m to the power n to the base a can be written as n into logarithm of m to the base a. Here n log means n into logarithm of m to the base a. These are the three major formulae which we will use to solve the exercise 1.5 sums. These are the major three formulae. First law of logarithm, second law of logarithm, third law of logarithm. Or else logarithm of a product, logarithm of a quotient, logarithm of a exponent. Clear? Next, fourth one. In general, here a base is there. For a logarithm of a number, power is there. If the power is also exists in the base, then what will be the case? Logarithm of a number m to the power n and a to the power some p, let us assume, then it will be written as, here this power n is making as a product, right? In front of the log it is appearing, right? Now this base power will be in front of the log, that will divide n by p into logarithm of m to the base a. M by p into logarithm of n to the base a. Clear? Next, logarithm of 1 to any base. Logarithm of 1 to the log 1 to any base is 0. Logarithm of 1 to the any base is always 0. Please be remember, logarithm of 1 to the any base is always 0. Since a power 0 is equal to 1, if you write that is in the form of logarithms, then you will get 0, right? Next, sixth one. Sixth one is, next, logarithm of a number to the same base. Logarithm of a number, log m to the same base. Okay? Logarithm of a number to the same base. Logarithm of a number to the same base is always 1. Here in this particular problem, this m should not be 1. M should not be 1. Clear? In this case, m should not be 1. So logarithm of a number to the same base is always 0. Like is always unity 1. Logarithm of a number to the same base is unity. Like log 100 to the base 100, log 2 to the base 2, log 5 to the base 5, log x to the base x, like that. Clear? Next, this logarithm of m to the base a can be written as 1 by logarithm of a to the base m. Whenever you are writing in the denominator, that will be interchanged. Okay? 1 by log a to the base m. Clear? And it is also written as log m by log n or log a. Log m by log a. See, these are the forms of this log m to the base a. For every problem, for every law, we have a proof also. For every law, we have a proof. But as far as this exercise is concerned, you do not require any proofs, right? Whenever we will deal with a logarithms chapter full, then we will try to see each and every formula for each and every proof for each law. Okay. Now, whenever that depends on the requirement, if this is the form is arisen and I need to convert this into this form, then I use this. Okay. Depends on the requirement. I may use this or this. Clear? So please be make a note of it. Logarithm of product log m into log n to the base a is equal to log n to the base a plus log n to the base a. Log m by n to the base a is equal to log m by log a minus log n by log a. Next log m to the power n to the base a is equal to n into log m to the base a. Logarithm of m power n to the base a power p is equal to n by p into logarithm of m to the base a. Logarithm of 1 to any base is 0. Logarithm of 1 to any non-zero base. Logarithm of 1 to any non-zero base is always 0. Here logarithm of a number to the same base. Logarithm of a number to the same base is always unity. Here m should not be equal to 1 in this case, right? Next log m to the base a can also be written as 1 by log a to the base n, and that equal to log m to the log a. And one more property is also there. Logarithm of a to the power logarithm of n to the base a. A to the power, this is power, this log is in the power, a to the power log n to the base a can be written as 1. Means whenever the problem is in this form, we can interchange this base, this logarithm of number and this base. Okay. This total logarithm of n to this is in the form of a power x. X is here log n to the base a, and base is a. This base a and this n can be interchanged. So a to the power log n to the base a can be written as n. Clear? So these are the formulas which we need to remember before proceeding with the 1.5. Clear? Right. So let us start 1.5 exercise. Right, 1.5 exercise, first bit, determine the values of the following. So I have written in the first bit there are 9 sums. I have written few sums. First problem, third problem, fifth one, seventh one, eighth one, and ninth one, right? So almost all out of 9 I have, I'm going to say 6 problems. It's very simple. Whatever the laws just now we have seen, from those laws we have to use here. I will use only those laws. Okay. Now you need to find out the value of log 5 to the base 25. So only the thing is, you write this 25 can be written as how much in terms of 5 square now. So log 5 to the base 5 square. Now if base has power, then if you bring it up, what it becomes, is it multiply the log 5 to the base 5, or else will it divide with the log 5 to the base 3? It will divide, because we know that if logarithm of m to the base a power x is a, suppose, then it becomes 1 by x into logarithm of m to the base a. We have seen both at a time. That is logarithm of m power into the a power p we have seen. I have taken here in this particular problem here only base has power, not logarithm of number. Suppose if you take this is 1 power 1 also, you will get 1 by 2, like that. Okay. So according to this formula, so you can write this as 1 by x. This is here m is 5, x is 2, right? Are you following? Right. So now 1 by 2 to the log 5 to the same base 5. So what will you get here? 1 by 2 into logarithm of a number to the same base. Is unity no? So 1 by 2 into 1 is equal to 1 by 2 is your answer. Clear? In the similar way, now this can be written as, I am writing this 1 by 16 as 1 by 2 to the power 4. Why? Because the prime factorization of 16 is 2 power 4. Now here, this 2 power 4 I will write it as 2 to the power minus 4 to the base 2. Now exponent law, third law of logarithm of m power n to the base a is equal to n into logarithm of m to the base a. So same formula I will apply here, minus 4 into logarithm of 2 to the base 2. So what will we get here? Minus 4 into logarithm of base 2 is 1. So answer is minus 4. Clear? Right. Now here logarithm of root x to the base x. Simple here also, root x is nothing but x to the power 1 by 2. If you remove this root 2, you will get power 1 by 2. Here base x. So what will you get here? 1 by 2 into logarithm of x to the base x. So 1 by 2 into logarithm of x to the base x is how much? 1. So option is, our answer is 1 by 2 into 1 is 1 by 2. Are you following everybody? Next, logarithm of 0.01 to the base 10. 0.01 can be written as logarithm of 10 to the power minus 2, no? 10 to the power minus 2 is nothing but 0.01 to the base 10. Same formula, like exponent of logarithms. Minus 2 into logarithm of 10 to the base 10. So logarithm of a number to the same base is 1. So minus 2 into 1 is equal to minus 2 is your answer. I hope all you are with me. Right. Now this one. What is this solution? 8 by 27 to the base 23. So that is equal to logarithm of 8 can be written as 2 cube and 27 can be written as 3 cube, base 2 by 3. Logarithm of this can be written as 2 by 3 whole cube, no? So I will write 2 cube by 3 cube is nothing but 2 by 3 whole cube. Laws of exponents these are, not laws of logarithm. Laws of exponent a power n by b power m can be written as a by b whole power n. That is what I have written here. So this is again logarithm of m power n to the base 2 by 3. Means 3 into logarithm of 2 by 2, 3 the base 2 by 3. So which is nothing but 3 into 1 which is equal to 3. 3 is your required answer. Isn't it? Okay. Next. This one is many times for 2 marks question, this question is asked, right? Let us cross check here. This is in the form of a to the power x into a to the power m plus n formula, right? A to the power m plus n. So in the exponents a power m plus n is nothing but a to the power m into a to the power n. According to this formula, I'll split this 2 to the power 2 into 2 to the power logarithm of 3 to the base 2. Logarithm of 3 to the base 2. Now 2 square is nothing but 4 into. Now 2 to the power log 3 to the base 2. The last, while I am discussing the laws of logarithms, last formula I have discussed here. A to the power log n to the base a can be written as n to the power log a to the base a, which is nothing but n. So I will interchange this 3 to the power log 2 to the base 2. Can I? Since a to the power logarithm of n to the base a can be written as n only. Logarithm of a power logarithm of n to the base a is equal to n only. So which is nothing but n to the power log a to the base a. Now 4 into 3 to the power logarithm of 2 to the base 2 is 1. So 4 into 3 power 1 is 3. 4 into 3, 12 is your required answer. Clear? This is about the first bit of the 1.5 exercise. Clear? Right. Second problem. Write the following expressions as log n and find their values. Same here. We need to apply the logarithms formula. 2 log 3 is in which form? I'll try to write here. It is in the form of m log n, right? M log or else n log m. N log m to the base a is equal to logarithm of m to the power n to the base a, right? According to this formula, I'll try to write this. This can be written as logarithm of 3 to the power 2 minus logarithm of 2 to the power 3. Now this is equal to logarithm of 3 square means 9 minus logarithm of 2 cube means 8. This is again in the form of log m by log m minus n. Log m minus n is nothing but log m by n, 9 by 8. If there is no base means what is this value? If there is no base means common logarithm has base 10. Clear? Right. Now here this is in the form of logarithm of m minus logarithm of n is equal to logarithm of m by n. According to this I have written. Clear? I hope this is understood, right? Are you following, everybody? Please. Now this solution of this problem is same procedure. Whichever. Here 2 terms are there, here 3 terms are there, right? Now first you try to do this sum, right? Before proceeding with the sum, what you need to do? This is in the form of again this form only. N into log m to the power a is equal to m log m to the power n to the base a. So logarithm of 3 square minus log 2, right? Now which is equal to, now this is log a plus log b, log a by b, right? Or as log m plus log n is equal to log m into n. So logarithm of 10 into 3 square minus logarithm of 2. Since logarithm of m into n is equal to logarithm of m plus logarithm of n. Clear? Now logarithm of m is nothing but 10 into 9 log 90 minus log 2, right? Now logarithm of 90 value means log a minus log b, log a by b, no? Logarithm of 90 divided by 2. Since log m minus log n is equal to logarithm of m by n. Clear? Logarithm of a product formula I have used here. Logarithm of a quotient formula is also I have used here. M by n is equal to log m minus log n. And in the first step itself I have used this n into logarithm of exponent also I have used. All the first three laws I have used in this formula, right? Now logarithm of 90 by 2 means 45, right? 45 to the base 10. Here log 9 by 8 to the base 10. They asked here write the following as expressions as logarithm of something n and find their values. Means n value you need to find. What is n value here? Here n value is 9 by 8. What is here n value? Here n value is 45. Clear? It's very simple once you know the laws of logarithm and its applications, right? Right. Next problem. After this is the second bit, and first 1, 2, 3 bits are there, very simple. First problem is about log 2 plus log 5, that is log n plus log n. This is in the form of log n plus log n, where this is first one. This is log n plus log n, log m into n, that is first one. Second one is log 16 minus log 2, is nothing but like this, log 16 minus log 2. This is only formula, let us assume. So from this you have to conclude, right? The third one is m log n, means 3 log 4. Like this one, 3 log 4, 2 log 3 is there, 3 log 4. This is only one term is there. So write that as log 3 to the power 4, which is nothing but log 81, like that. Okay? So this is about second bit. Clear? Next. Right, next problem. Evaluate the following in terms of x and y. If x is equal to log 3 to the base 2, y is equal to log 5 to the base 2. Clear? So here log 7.5. Okay? Log 7.5 can be written as logarithm of, I'll write this as 75 by 10. Okay? So if you remove this decimal point, you will get down 1, and after the decimal point 1 digit is so you will get 1. Now if you simplify it, 5 2s are 10, 5 1s are 5 5s are 15 by 2, right? So logarithm of 15 by 2 to the base 2. Now this is in the form of logarithm of m by n, log m by log n, log 15 to the base 2 minus log 2 to the base 2. Since logarithm of m by n is equal to log m minus log n. Done? Now again this 15 can be written as 3 into 5, right? Log 15 can be written as 3 into 5 minus logarithm of a number to the same base is 1. So next log a plus b. Log a into b is nothing but log a plus log b. Log 3 to the base 2 plus log 5 to the base 2 minus 1. But as per the problem, log 3 to the base 2 is given as 6, x, and log 5 to the base 2 is given as y. So x plus y minus 1 is your required expression. So the expression in terms of x and y, log 7.5 to the base 2 is x plus y minus 1. Right? Now let us see this problem. First problem is log 15 to the base 2. Only this part is first problem. Log 15 to the base 2 into log 3 into 5. Log x plus y. X plus y you will get. Only this part you will get. That is about first problem. Now second problem is log 60, right? Second problem is log 7.5 this only, and third one is log 60 to the base 2, and fourth one is log 6750 to the base 2. So first one is over, this one in this part only first one, and this is second one, and third one is log 60. Just you have to prime factorize it. This I will say according to this you can do it. Okay, 6750. First you do the prime factorization of 6750. Okay, so let us go start with 5. Or else 2, no problem. 2 table you can start. 2 3 is a 6, 2 3 is a 6, 2 7 is a 14, 2 5 is a 10. Next to 5 table. Will it go in 3 table? 3 plus 3 6 plus 11 18. Yes, 3 table it goes 3 1 the 3 1 the 3 2 the 3 5 the. Again it goes in 3 table. 3 3 is a 9. 22, 3 7 the 21. 3 5 is a 15, right? Again it goes in 3 table. 3 1 is a 3, 3 2 is a 6, 3 5 is a 15. Now 5 table. 5 2 is a 5 5 is a. Again 5 1 is a 5 5 is a. So this is the prime factorization of 6750. So 6750 can be written as 2 into 3 square into 5 cube. 1 2 3 cube, sorry, 3 cube into 5 cube, right? So I will replace this 6750 by 2 into 3 cube into 5 cube, right? Now this is in the form of log base 2. Now this is in the form of log m into n. Log m into n, and one more number O is also there. M into n into O, A into B into C into Z, like this if you take, that will be becomes the sum of the logarithms. Log A plus log B plus log C plus log C and so on, log B, like that. Okay, here only 3 terms are there. You can expand this also. Log 2 plus log 2 to the base 2 plus log 3 cube to the base 2 plus log 5 cube to the base 2. Now it can be written as now it can be written as 1 plus this can be written as 3 log 3 to the base 2. This is 3 log 5 to the base 2. Right? Now that is equal to 1 plus 3 log 3 to the base 2 is given as x, and log 5 to the base 2 is given as y. So 1 plus 3x plus 3y is the expression in terms of x and y of logarithm of 6750 to the base 2. Clear? For the third problem, log 60 to the base 2 is given. For 60 you do the prime factorization in the same way you proceed. Right? This is about third problem. Clear? Fourth problem, expand the following. Log 1000, log 128 by 625, logarithm of 6 x square by 2 z power 4. Fourth one log p square q by r, and fifth one is logarithm of under root x cube by y square. Now it's very simple. For this problem and this problem, you need to do the same. In the previous case, we have did prime factorization. Same procedure we need to follow here. Right? So log 1000 can be written as. So first problem answer is. So I am writing this prime factorization. If you do, you will get this 2 into 5. Right? This is 10 cube, no? So otherwise I write this in the form of 10 cube. Okay? So what will you get? That is equal to logarithm of 2 into 5 10 whole cube I will write. Now logarithm of this can be written as 3 log 3 log 2 into 5. This can be written as 3 into log 2 plus log 5, right? Next, expand reset, so split it. 3 log 2 plus 3 log 5 is our required expression for the first one. Similarly, second problem, 128 is can be written as 2 to the power 7. 625 can be written as 5 to the power 4. This you write first of all log 128 minus log 625. Then log 2 to the power 7 minus log 5 to the power 4. Then 7 log 2 minus 4 log 5 is your required answer for this. Clear? Otherwise you can write down, no problem. This can be written as log 128 minus log 625. You have to write, you have to mention the formula also. You have to write, everybody. Next, logarithm of, if you do prime factorization of 128, it becomes 1 to the power 7 and this becomes 5 to the power 4. This becomes 7 log 2 minus 4 log 5 is your required answer, right? Next, third one, logarithm of x square plus y cube plus z power 4, that is in the form of log a plus log abc. Log a into log b into log c means log a plus log b plus log c. Log x square plus log y cube plus logarithm of z power 4, right? This is z. Now this can be written as 2 log x plus 3 log y plus 4 log z is your required expansion. Clear? This is first one expansion. I hope you all are with me. Right, next. Fourth one. This is minus this. Okay. You can do it here. Fourth answer. Logarithm of a by b. Log a minus log b. Logarithm of r. So which is again this is in the form of log a into b or log x into y. Log m into n. Log m plus log n. Okay. It's very simple once you know the formula. So this can be written as 2 log p plus 3 log q minus log r is your expanded form of logarithm of p square q cube by r. Right. Next, last one but not least, this can be written as logarithm of root is nothing but whole power 1 by 2, right? X power. Otherwise, you separate the root for both. Okay, root x cube by root y square. So this square root and gets cancelled. This can be written as logarithm of root x cube is nothing but x power 3. Root if you remove you will get 1 by 2 power minus log y. Right? Now here what will you get? Logarithm of a power n whole power n. A power m into n. Log x to the power 3 by 2 you will get minus log y. Now 3 by 2 log x minus log y is your required expression. I hope you people are understood, right? Simple, nothing I have done. In the first two problems you have to do the prime factorization of the given numbers. See, I have no, because I knew it 128 prime factorization is 2 power 7 I will get. So if you do not know, you do separately 128 prime factorization, then you write it in exponential form, then you will get this. 625 also, if you write in exponential form, you will get 5 power 4. Clear? So I have applied first law, second law and third law only in all these three. Clear? Right. This is about fourth problem.